Chromium-6, also known as hexavalent chromium, is a chemical compound in which the element chromium resides at the +6 oxidation state. It is classified as a carcinogen, although not all of the acute and chronic side effects it produces are carcinogenic. Its molecular formula is Cr+6. The main use of chromium-6 is in manufacturing process, mostly to coat steel and other alloys. Examples of this include stainless steel cookware and chrome plating. Chromium-6 is also used to treat wood in order to preserve it. Products such as copper dichromate are examples of this. Thirdly, chromium-6 is used in the dyeing/pigmenting of textiles, with the primary material being leather. Chromium-6 occurs naturally from the erosion of natural chromium deposits. However, it is mainly from these manufacturing processes that chromium-6 is introduced into the environment. There are two main forms in which it can be released. The first is via the air. This occurs when chromium-6 is used for some processes, like chemical plating, and minute amounts flume up into the air in the form of dust-like particles. The second way chromium-6 is introduced is by seeping into the groundwater. This happens after chromium-6 is used as an ingredient in something like fertilizer or cement, for example, and is then combined with other materials into wastewater. This wastewater is pumped into evaporation ponds. There have been many well-documented cases of these evaporation ponds not being properly lined. When a pond is not properly lined, the contaminants of the pond are able to seep into the ground and contaminate the groundwater. The risk of chromium-6 in the environment is not as great as other toxic materials because chromium is naturally occurring. However, chromium-6 that gets into the groundwater can have devastating effects. Airborne chromium-6 only remains a threat while being circulated around inside a factory, for example. As soon as the air leaves the factory and mixes with the outside air, the risk is mostly diminished. However, chromium-6 that seeps into the groundwater can be present for a much longer period of time. This contaminated water has a large impact on aquatic habitats. Studies have shown that chromium-6 alters the gills and liver of many different types of freshwater fish. The main risk of having chromium-6 in the environment is adverse health effects it has to humans. As mentioned earlier, chromium-6 is a carcinogen, which means that it is cancerous. Many times, chromium-6 is released by manufacturing plants into the air. This forms the chromium dust that was mentioned earlier. This can lead workers in these plants to develop lung cancer, which can form when the chromium dust gets trapped in the lining of the lungs. Even if a person does not get lung cancer, there are many non-carcinogenic effects that airborne chromium-6 can have, such as bronchitis.
And then the smoke got me. I got bronchitis. Ain't nobody got time for that.
If the chromium-6 is able to seep into the ground, it can contaminate the groundwater. When chromium-6 touches the skin, lesions called chrome holes form, which produce an open sore in the skin, or an ulcer. These ulcers can be extremely painful. If enough chromium-6 is ingested through either of these two methods, it can lead to death. The amount of chromium-6 that can kill a person is called the lethal dose. The lethal dose of chromium-6 is between 50 and 150 milligrams per kilogram, depending on their sensitivity to the toxin. As is the case with most carcinogens, chromium-6 affects young children more than it does adults. So what can we do to reduce the amount of chromium-6 that is ingested by humans? Well, chromium-6 is already regulated by the EPA. Under the Safe Drinking Water Act of 1974, the EPA set the standard of 0.1 milligrams per liter, or 100 part per billion, of chromium-6 in a body of water to be considered safe. The Safe Drinking Water Act requires the EPA to determine the level of contaminants in drinking water at which no adverse health effects are likely to occur. So at 0.1 milligrams per liter of chromium-6 in a body of water, no adverse health effects should occur. Chromium-6 is also regulated under the Clean Air Act of 1990. Another simple way to reduce chromium-6 intake is by not using it. Many substitutes exist for the variety of tasks that chromium-6 is used for. For example, chromium-6 is widely used for chrome plating and other likewise techniques. Instead of using chromium-6, chromium-3 could be used. Chromium-3 is actually essential to humans to live and is found naturally in our bodies. Chromium-3 also has been found to be an ample substitute to chromium-6, providing the same and even if not better results for these plating techniques. This switching will create a safe working environment and will reduce pollution during the planting process.